Okay, I just started the recording for our chemistry review session. So Jessica and Abby, I guess you guys are the only ones here. I was expecting a much bigger crowd, but that's what we've got. So I'm opening the floor for questions that you might have regarding the upcoming 30-point chemistry exam. What would you like to go over? Where are you in the process of studying, preparing for that?
What would you say the most important formulas for us to know for the exam are?
Well, there aren't really a whole lot of specific formulas you would need to memorize. I mean, I think I may have mentioned in class, like glucose. I think I would probably know the formula of glucose. Do you know what that is? C6.
Not right off the top of my head.
Okay, C6H12O6. That's the chemical formula of glucose. It's actually the chemical formula of some other sugars, but we're going to just keep things simple and say, if you ever see C6H12O6, that is going to represent the monosaccharide glucose. I mean, really, if I said water, if I said carbon dioxide, would you know the chemical formula of those? I would hope so. If I said oxygen gas, would you know what the chemical formula of oxygen gas is? O2, right? So I'm not going to be asking you to regurgitate a lot of chemical formulas or anything like that. I think you need to be able to recognize a polysaccharide if you see it, a monosaccharide if you see it. I think you ought to recognize a peptide bond if you see it. I think you should recognize a triglyceride molecule if you see it. These are all things that chapter 2 talks about. We can pull these up if you want to do that. But I'm not going to ask you to draw out a lot of chemistry. No, not at all. That's not the purpose here. This isn't, it's the chemistry chapter, but this isn't chemistry class. So to answer your question, other than just a couple, I would not worry about chemical formulas. Yeah. Have you gone through the objective listing? I think I mentioned in class that would be probably a good way to study for this, is to pull up those study objectives, which I have here. You see those? You guys see those on your screen?
Yep.
Okay. I think those are a good set of guidelines that you can use to kind of help you in the process of knowing what topics to cover. So have you looked at these? And if so, are you good with these? Do you want to ask questions about these? Again, this is your opportunity to ask questions. I'm not going to lecture on chapter 2. This is a review. So you need to come with questions or say, could you go over this?
So we will be like calculating the atomic mass, well, number and stuff like that, right?
Well, if I gave you the atomic numbers of the individual elements, for example, if I say like glucose, C6H12O6, to calculate the total, atomic number for, say, that compound, you would add up the individual atomic numbers of the individual elements. Right? But I would give you those numbers. I wouldn't expect you to know that the atomic number of carbon is 6 and the mass number is 12. I mean, it's just not something you're going to know. But you need to understand the concept of what is atomic number, what is the mass number, or what books used to call the atomic weight. So what is the difference between atomic number and the atomic weight? This is objective 4. Anybody know what the difference is? Atomic number? How do you calculate that?
Neutrons plus electrons.
Not
For the atomic
number.
Periodic table.
Well, yeah, you could look at the periodic table and find those values, the atomic number and the mass number for each element. That's true. But by definition, the atomic number is the number of protons in the nucleus, which is the same as the number of electrons spinning around the nucleus. So you're not adding them together like you do the mass number. And the mass number, atomic mass or atomic weight, is the number of protons plus the number of neutrons. Okay, so if you look at any element, let's just again go to the PowerPoint for chapter 2. I'll share that. I'll just pick a slide here if I can. Oh, let's see. Okay, so here's sodium at the bottom of this figure 2.3. It's indicating to us that in the nucleus of a sodium atom are 11 protons and 12 neutrons. And of course, in blue are showing the electrons in 3 different energy levels. Note that the first energy level can contain a maximum of 2 electrons. The second and the third can carry or hold a maximum of 8 electrons. Once we get beyond that to 4th or 5th or other higher energy levels, the numbers can change in terms of how many electrons could be found in any given energy level. But for our purposes, I want you to know the first energy level, or shell, some people call it, maximum of 2, second and third maximum of 8. In the case of sodium, you can see its first and second shells are filled, and it has 1 electron called a valence electron. Those are the electrons in the outermost shell. It has 1 valence electron. So back to what is the atomic number? What is the mass number of lithium? Well, you tell me, what's the atomic number? Well, it tells us here, right? That means there are 11 protons in the nucleus. There's also 11 electrons spinning around. 2 plus 8 plus 1 is 11. To calculate the atomic weight, we have to add the number of protons and the number of neutrons, which in this case, of course, is 23. If I asked you to look at the helium atomic structure here, can you tell me what the atomic number of helium is? Did you guys hear me?
Yes.
Okay. So what's the atomic
two?
number of helium? It's the number of protons in the nucleus, which is the same as the number of electrons spinning around.
2.
2. What is the atomic weight of helium?
4.
Right. Yep. You add neutrons and protons, right? How about lithium? What's the atomic number of lithium? I'm sorry?
3.
Yes. And the atomic weight?
Six.
No. Seven. It's the number of protons, which are 3, and the number of neutrons, which are 4. Look in the nucleus. Okay. So that's the difference between atomic number and atomic weight. How about other questions?
I'm just letting you know I have to leave. I have to go to my next class.
Okay. Thank you.
I was just about to say the same thing. I have to get ready for my 11:30. I did have a quick question though. Are we going to be able to use or need the periodic table of elements on the exam?
No, you
Okay.
won't need it.
No, you won't need it.
And if you did, I would
If you
provide
did,
it
I
for you.
would
but-
provide it for you.
Okay, thank you so much. And you said that this is being recorded, so I'll check it out later and see if anybody else ended up getting on or whatnot.
Yeah. In all likelihood, you guys may be the only two. I will probably stop the recording and then I'll stay on Zoom. And if somebody pops in, I'll re-record a second video, but we'll see if anybody shows up, but this may be it, unfortunately. You can also go back and look at one I did last spring, and I did not look at it, so I don't remember, to what extent there's lots of questions. So I fully expected more people today. I'm a little disappointed, to be quite honest. I thought we'd get better.
Me
turnout.
too.
Yeah.
Me too. I thought it was going to be a lot more fun.
Well, yeah, it's hard to find a time with everybody's schedule, I know, and you got classes at 11:30, so I won't keep you, but yeah. Thank you for showing up though, guys. I appreciate it.
Thank you.
Okay,
Thank you.
see you later. Yeah. Bye.